Today we are going to solve LeetCode 198, which is called House Robber. So this is an easy question, but it's a beautiful question to start with DP. So let's start. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security system connected. So there's some storytelling, and it will automatically contact the police if two adjacent houses were broken into on the same night. So given a list of non-negative integers representing the amount of money of each house, determine the maximum amount of money you can rob tonight without alerting the police. So basically, this asks what is the sum of the elements that you can choose from an array when you cannot choose adjacent elements. So here, let's say we choose this one and we cannot choose 2 anymore. So we have to choose either 3 or we do not. So if we choose 3, we have like 1 plus 3, which is 4. Otherwise, we could have, if we do not choose 1, we have 2, we cannot choose 3, and we can choose 1, so we would have 3. So the answer is 4 in this example, and in this example we can start from 2, 9, which makes 11, and 12. On the other hand, we could get 7 plus 3, which is 10, so 12 is better. So let's see some constraints. So the length of the array is smaller than or equal to 100, and each number is smaller than or equal to 400. So it's a straightforward question. So the algorithm will be start from either end. So we can start from left hand side or we can start from right hand side, it doesn't matter. And calculate the amount of money if you choose a house or not, and take maximum. So that's what we are going to do on each step, and we can at the end calculate like the best solution for 0th and first house, let's say, and we will just compare them, and the maximum will be our result. So let's write the code, it will be a lot easier to understand. So let's say we have an array here, and it has n elements, like this thing. Oh, let's define n first. Set size. So let's all initialize to be 0. So we will change some of them, like dp0 is going to be num0, because if we have only the first house, that is how much we can earn, that is the maximum. Are they non-negative, by the way? Let's see. Yeah, they are non-negative, so we can always choose. So what about the first house, the second house actually, but it is indexed the first. So we can either take that house or the first house. So it is going to be the maximum of num0 and nums1, or dp0, right? So we take the maximum and put here, and we do not actually need to calculate any other dp, we will just do it iteratively. So I is equal to 2, I is smaller than n plus 1, because we will calculate, we do not need nth house, because nth house is actually indexed at n minus 1. So what we are going to have is, we are just going to calculate if dpi is going to be either take it or leave it. Like if we take the house, what's going to be what's going to be the result? Let's see. We will certainly include nums_i, but we cannot include the previous house, right? So we will have to include 2 previous houses because we cannot sum it up with the previous house. So otherwise, this is take it, by the way. If we do not take it, what we can do is we can just take the previous house's value. We just leave this house and we have the best value as the previous house's value, previous dp's value actually. So at the end, what we are going to return is dp. Okay, the answer is going to be dp n minus 1. but we may have some edge cases. So if n is equal to 0, meaning we do not have any element, we should return 0 because that's the maximum thing we can have. Or we can have like n is equal to 1, we do not cover that case here. We should return nums 0, which is the first element, that is the maximum thing we can gather from this. So let's run this. And apparently it's accepted and pretty fast. But can we do it better? I mean, not time-wise, but space-wise. Actually, we can. We can just use two variables here, or like three. Let's try that. So let's say this is my first integer, and let me call that first. And the second one will be this one, and I will keep a temp. This looks like a I don't know, Fibonacci sequence here, but it's not exactly the same, of course. So we will do it again like this, but what we are going to do is we are just going to update this second and first elements using this temp, of course. So what's going to be the second one? Let's see. Second one is going to be take it or leave it. This thing here. Actually, let's make it on this. Yeah. We can take nums I, which is our element, and this is I minus 2, which is the first one, right? So let's make it first. And this is going to be the second one. So second is updated in this way. But before that, let's just keep that value of second, because if the value of second changes, we cannot update the first. And let's make first temporary. And what we are going to return is the maximum of first and second, because the optimal solution could be like starting from this one or this one. That's why. So I think this would work. Let's start. Works on this example. And works here too. This is some, I don't know, I don't know the meaning of this. I mean, this has the same time complexity with the previous one, but better space complexity definitely, because we have like constant space used here, 3 variables, and only the array they give us, right? So our solution has, in this case, O(n) time complexity and O(1) space complexity. So thank you very much for watching.